right, let's start with number 5. This one we have to find all that information and do the graphing for it. Here we have f of x is equal to, I missed that negative sign the first time I saw this. Anybody else miss it?
No, I saw it.
All right. I'm going to go ahead and put it up there with the numerator so it has a home, right? Okay. Can I factor?
No.
Of course I can, right? Not the numerator, but I can the denominator. I get x times x minus 3, right?
Yes.
Let's go ahead and find my points of discontinuity. Any holes? Nope. Vertical asymptote. X equals 3 is one of them. And x equals 0, yeah. We have 2 factors in the denominator, right? We have an x and an x minus 3. So that means we have 2 vertical asymptotes.
If there's 3, it's like x minus 3 and x plus 2.
Then we would have 3 vertical asymptotes, yeah. Doesn't happen often, but it is possible. Okay. Now what I would do, as soon as I have the vertical asymptotes, I go ahead and I graph them. And it is helpful if you use another color to draw in your asymptotes, just so you can have a different look, you know, where you can tell the difference between where your boundary lines are and what is your graph.
I ain't got no color.
I do have some colored pencils if you would like to use some colored pencils. So we're starting off like this. X-intercepts are next. What do you think on x-intercepts, everybody? None. There's not even an x in the numerator, is there? So this will never ever touch the x-axis. And finally, let's talk about our horizontal asymptote. All right, degrees. Degree of the numerator. 0. Degree of the denominator.
2.
Bigger than 0, right?
Yeah.
All right, so what's the rule?
What is it?
Y is equal to 0. It's the x-axis, isn't it?
Yeah.
All right. So let's go ahead and draw that one in. So we have our boundary lines. We've done all this work, and we still don't even have a point, do we? Not even a point. Okay. Doesn't take much to get them. Because we have 2 vertical asymptotes, we actually have 3 regions where we're going to have some graphs. We're going to have to see what happens to the left of x is equal to 0. We're going to have to see what happens between the 2 vertical asymptotes, so between 0 and 3, and then what happens to the right of 3. You with me on that? So to the left, we have to see what happens over here, because then we have a break. We have a point of discontinuity at 0. Then something happens in between, in the middle there. And then there's another break. There's a point of discontinuity. There's another asymptote. And then we have something happens over to the right. So we have to have 3 different XY tables.
Why wouldn't there be 6? Because of the flipping. The 1, 2, 1, 2, 1.
Well, we're not going to have something that happens up here and then something down here, because then it wouldn't be a function. Remember that whole vertical line test? It wouldn't happen, would it? These are all functions. So we're not going to have something in the top and in the bottom. So it's just to the left of 0. So all you have to do is you pick 3 numbers that are to the left of 0. What would be the obvious choices here?
1, 2, 3. Negatives.
-1, -2, -3? Make sense?
Did you choose 0? Oh, yeah.
You could not choose 0. Why not?
Because you can't touch the asymptote.
Yeah, it's an asymptote, right? Yeah. Makes the denominator become 0. It's undefined. Okay, so let's go ahead and do that. Let's put a -1 in for x. Now, I find it easier to put it into the factored form. Now, that's what means we're putting it into this function, -4 over x times x minus 3. So you're going to put a -1 in for the x, both of those x's there. You with me on that? So this is when it's nice to have a little piece of scrap paper off to the side, right?
Got it.
And we're just going to put those numbers in. I can put it up here because I can keep erasing, right? And then -1 minus 3, right? Let's see, and that becomes +4 in the bottom. And then that's -1. And then you got to put in a -2. And then you got to put in a -3. It starts to go pretty fast. And you can keep them as fractions or turn them to decimals. It really doesn't matter. Let me know when you have an answer for -2.
It is 2 over -2 over 5.
-2/5?
Yeah.
We got confirmation on that? Okay, -2/5. How about if we put in a -3? -2 over 9. Very good. So let's go ahead and plot those 3 points. So -1, 1. I mean -1, -1. -2, -2/5. So we're getting kind of closer to that asymptote, aren't we? And then -3, -2/9. We're even closer. So do you start to see what's happening here?
It's a little curve.
It's a curve. It's getting closer and closer to that asymptote. And then it has to make a turn here because it runs into another asymptote here. And you're going to see this shape happen a lot over and over again in these shapes. In these graphs, you'll see that happen. All right, let's see what's happening here in the middle. We'll make a little XY table.
Can we only do 2 spots?
Well, we can always use fractional spots, right? Ones in between. But let's start off by just using the whole numbers, because that might be enough to let us know, right? What numbers should we use?
1,
1
2.
and 2. All right. Yes. Well, just to start off with whole numbers, there's only 2 whole numbers between 0 and 3. If we feel like we need to put another number, we can. We can use a fractional number. But we'll start off with just 1 and 2 for now. What'd you get when we put a 1 in?
I have 4 over -2.
So what's 4 over, are you sure you got 4 over negative? Is it -4 over -2?
Yeah.
So that's +2?
Yeah.
Okay. What'd you get when you put a 2 in?
I didn't do that.
Anyone else? Yeah, try that again. We got +2 again. Huh.
Wait, what?
It's just a straight line.
Yeah, right? So if you put a 1, you get a 2 in, you get a 2, you get a 2 in. Could it really be a straight line?
It's a
It's probably not a straight line.
it's a parabola.
It might be more of a curve shape, maybe a parabola. We could put another point in to see, right?
But what?
Maybe 1.5, maybe something in between. Yeah, let's see what happens if you put a 1.5 in. It does seem strange that we knew it's not going to be a straight line, though, right? But it's not in between the 2 asymptotes.
1.6.
Okay, you try 1.6. Everybody else is going to put 1.5 in. For x, huh? Wherever you see an X, you put the number. Okay. Got it.
Shut up. What did we get?
Um,
Hopefully it's not 2 again, or else we're in trouble.
it's
$1.
It's what?
1.8.
It's 1.8, so it's a little bit less?
wait,
Yeah.
I didn't get 3.
wait. 1.5 times 1.5.
Everybody agree it's 1.8?
Yeah.
Can we do that out?
We got 1.7.
I don't think I got the correct. I did not get the correct.
If we round. We did it.
Well, I mean, I could on a calculator. Can I borrow yours?
1.5 minus
So I would do 1.5 minus 3, right? And then multiply that by 1.5, right? And I'm going to take negative 4 divided by negative 2.5.
oh, so I got it.
So 4 divided by 2.25. So like about 1.8. Okay.
It's a little.
So it's down a little, isn't it? Okay. So I think whoever said it, maybe it looks like a parabola might be right. Because we do have these asymptotes, right, on either side. All right, now we have that one last region over here to the right. What numbers should we test?
4, 5, and 6.
4, 5, and 6. All right. I think we get negative 1 there for 4.
Yeah, negative. It's a
We
negative.
got 4. Oh, JK. I see what I did.
Yeah.
And then 5. Negative 2/5.
And then negative 2/9.
We get 2/9 again?
Yes.
So do you see that kind of symmetry going on? Look at your table you had for the other side. Negative 2/5, negative 2/9. Okay. It's not always the exact same, but you will start to see some symmetry going on as you graph these. Now the last thing I'd like you to do is to check this on Desmos or check this on a graphing calculator. Okay. That's always a great idea to check and make sure that what you did actually made any sense.
Do that.
Now on Desmos and on graphing calculators, you're not going to see those dashed lines. They're not going to show you what the boundary lines, those asymptotes. So it's important that you've already done all this work ahead of time, and that you're just using the graphing tool to check, not to do it for you. It will be painfully obvious to me if you just simply put it into the graphing calculator and try to somehow come up with a sketch. It will be so obvious. So, like, you're not going to get points for that. Does that make sense? There won't be any points. So make sure that I'm seeing your tables that you're making, that I'm seeing their factored forms, that you're showing me your points of discontinuity and your x-intercepts and your horizontal asymptote, that I'm seeing all of those steps, that I actually see that you're drawing in your asymptotes. That's what's going to make all of your points. This last step of checking on the graphing calculator is just to confirm that what you did was right. Does that make sense?
Yes.
Awesome. Now, if I had had a hole at this point, if I had found that there was a hole somewhere in the problem at the very beginning, now is when I would go through and I would put an open circle. So let's just make believe at this point. Like, you don't write anything on yours. I'm just saying, here in purple, I'm making believe at the very beginning, maybe I had a factor of x plus 5 at the very beginning, okay? I'm making this up. This is pretend. You with me on this? This is pretend. Okay. So if I had had a factor of x plus 5 that's simplified, that would mean I would have had a whole at x is equal to negative 5, right? So now I would go back to my graph and I would find where x was negative 5. So 1, 2, 3, 4, negative 5, right? And it's not on the x-axis, is it? Because it can't touch it. It's just right below it. I don't have to make a table where I actually figure out the exact value for y when x is negative 5. All I have to do is on the line that I've drawn, I just have to do a little open circle there to show that there's a hole at that location. That's all you have to do to show that there's a hole. So at the very end of the graph, or at the end of the problem, you go back and say, okay, there was a hole wherever x was negative 5. And you go to that point and you put an open circle there. Your calculator won't know to do that, but you do. Does that make sense? There aren't very many holes in this whole worksheet. It only happens a few times, but I want to make sure you don't miss those. Do you have the steps? All right, cool.